Good morning, students. Chapter is congruency of triangles. Yesterday we studied about the theorem. Yes, say yes. Now, continuation of the same chapter, congruency of triangles. Second theorem, ASA. ASA. From the notation itself, can you say what is ASA? How many angles are? Two angles and one including side. How can you state that ASA? If two angles and included side of one triangle is congruent to the is equal to the two angles and included side of the other, we can say that two triangles are congruent. What's the condition? If two angles and included side of one triangle is equal to the corresponding two angles and the side, one side, then we can say that by ASA, these two triangles are congruent. Our aim is to prove that. Look at the figure, draw the figure. Here one arc, then here two arcs. That means angle A equal to angle D and angle B equal to angle E, and this, draw the figure. From the given figure, we can write, look here, angle BAC. Remember one point, when you write the angle, use how many letters? 3 letters, and the middle letter shows the angle. When you write an angle, always write 3 letters, not write direct angle A in this way. That is also correct, but usually when you denote one angle, use 3 letters. That's very important. Therefore, BAC means that angle is A. The middle letter shows the angle. Here from the figure, angle BAC is equal to angle EDF. EDF. Agree? What's the reason? We can write this as given. From the question itself, we can write. What's the next case? Angle ABC is equal to angle DEF. That is also given in the question. Then which is the included side? AB. AB is equal to, from the figure, AB is equal to DE. That is one side. Here this is an angle AS. Therefore, by which theorem? By ASA, we can say that triangle ABC congruent to triangle DEF. ABC congruent to triangle DEF. That is by which theorem? ASA. The next theorem, right? Next theorem, yes. Next theorem, yes. Look here, AB 1 mark, DE 1 mark, BC 2 lines, here also 2 lines, and the AC 1, 2, 3 lines, and DF also 1, 2, 3. Then how can you state SSS congruency theorem? Same sentence. If 3 sides of one triangle is equal to the corresponding 3 sides of the other. Repeat. If 3 sides of one triangle is equal to the corresponding, that word is important, is equal to the corresponding 3 sides of the other, then we can say that by SSS congruency theorem, that two triangles are congruent. Okay, we can write, what is the first one? AB is equal to DE. From the figure itself, that is given. Here one line, here one line. Very simple. One line, one line. That means AB equal to DE. That is, what is the reason? Reason is given. What about the second? BC is equal to EF. That is also given in the question. And the third one, AC is equal to DF. AC is equal to DF. Therefore, by which theorem? All these are sides, isn't it? Therefore, yes sir, yes sir, yes sir. Right. Therefore, write that. Therefore, by yes, yes, yes. SSS congruency theorem, that two triangles are congruent. By SSS congruency theorem, that two triangles are congruent. Therefore, we can write triangle ABC congruent to triangle DEF by SSS congruency theorem. Then, next theorem is AAS. What's the meaning AAS? Two angles and one side. From the notation itself, two angles. If two angles of and the side, including sides of one triangle, is equal to the corresponding two angles and one side. Same way you can prove that. Then one more is by RHS. Right? By RHS. That means we take a right-angled triangle. Two right-angled triangles are there. Then only we can apply RHS. Two right-angled triangles are congruent. Keep the hypotenuse and one side. If the hypotenuse and one side is equal to the corresponding side of hypotenuse and one side of the second triangle, then we can say that by RHS they are congruent. That means if it is ABC is a right triangle at B, DEF is right angled at E, then we know that 90-degree opposite side is hypotenuse. 90-degree opposite side is hypotenuse. Here AC is equal to DF. Understand? And the second side BC is equal to EF. Then by RHS theorem we can say that these two triangles are congruent. In this chapter, our aim is to prove the figures, triangles are congruent. For that, write one question. Write one question. Draw the figure. Write the question. Right. AB be the chord of a circle and O is the center. P is the midpoint of AB. Prove that. Right. Prove that. Draw the figure. Our aim is to prove that. Right. Question. Prove that triangle OAP congruent to triangle OBP. The question is prove that triangle OAP congruent to triangle OBP. Understand? Can you see where is the triangle OAP? Look here. In this question, O is the center of the circle. Therefore, we know that this OA is the radius. Therefore, you can join that radius. And same way, OB is also the radius. OB is also the radius. Then, how can you prove the congruency of that two triangles? First one, right. When you prove one theorem, first step is you have to write what is given in the question. Look here. In this question, our aim is to prove that triangle OAP congruent to triangle OBP. When we prove congruency, main three steps are there. First one is read the question. When we read the question, here the condition given is P is the midpoint of AB, that is given in the question. Therefore, the first step is given part. Understand? One is given part. What is given? P is the midpoint. P is the midpoint. Look here. How can you convert that sentence into mathematical notation? Look here. Suppose this AB is equal to 6 centimeter. AB is a 6 centimeter line. And I say that this P is the midpoint. Understand? P divides AB equally. P is the midpoint means, can you say what is the distance AP? That is 3. Isn't it? And this BP is also 3. That is why AB is equal to 6 centimeter. P is the midpoint means, how can you write that in mathematical notation? AP is equal to BP. In this question, what is given? AP is equal to BP. From which sentence? P is the midpoint. Understand? Now listen. Second point is what we have to prove. That means to prove. When we write the theorem, what's the first step? Given. What is given in the question. Second one is what we have to prove. What we have to prove? We have to prove that triangle OAP congruent to triangle OBP. That is our aim. Our aim is to prove that two triangles are congruent. And one more step here, one more part is here. Prove that OP is perpendicular, or angle OPA is equal to angle OPB equal to 90 degree. That is also our aim, to prove that OP is the perpendicular means angle OPA is equal to angle OPB equal to 90. Understand? Then, as you know that in this question, not this OA and OB actually given, isn't it? This is the question part. But when we write the answer, we join this OA and OB. Therefore, actually one construction part anyway, right? Join, third part, join, or you can write construction, is join OA and OB. Join OA and OB. Okay, these are the first three parts. Now our aim is to prove that these triangles are congruent. Listen carefully. That means write the next step, prove. Prove. Then one side write statement. And the other side write reason. One side write statement and the other side write reason. Understand? We know that we can apply SSS, SAS or ASA or RHS. Isn't it? These are the theorems relating to prove the congruency part. Look here. First, from the given statement, our aim is to prove that these two triangles OAP and OBP are congruent. Number one. AP is equal to, here this is O and this is P. Change that. AP is equal to BP. AP is equal to BP. Can you state the reason? Yes, that is given in the question itself. That means given P is the midpoint. That means AP is equal to BP. AP is the side of the first triangle. BP is the side of the second triangle. Therefore, you can draw AP is equal to BP. The reason is given. Okay. Then second one is, can you say the second reason? OA is equal to OB. OA is equal to OB. What's the reason? They are the radii. Understand? Radii or radius. Or we construct that. Understand? They are the radii. We know that in a circle, all the radius are of equal length. Therefore, OA is equal to OB. What's the reason? They are the radius of the circle. Then look at the figure. Here also, this is the second condition. Look here, from these two triangles, any side is common. Which side is common? Yes, this OP is common to both the triangles. OPA and OPB. That OP side is common. Therefore, what is the third one? OP is equal to OP. That means, what's the reason? That is the common side. That is the common side. Understand? Once again, look here. Right? Actually, the answer starts here. Proof. Statement. Reason. What's the first statement? From the given term, we write AP is equal to BP. That is the side S. Then OA and OB are the radii. Therefore, that is also a side S. Then OP equal to OP common means that is also a side. Understand? Then how can you say that? By, right? By yes, yes, yes. By SSS congruency theorem, triangle, look here. Triangle, OAP congruent to triangle OBP. Triangle OAP congruent to triangle OBP. First we prove that the two triangles are congruent. Understand? What is the second part? Second part is our aim is to prove that OPA equal to OPB equal to 90 degree. All of you understand the first part? By SSS congruency theorem, we can prove that two triangles are congruent. Now listen, if two triangles are congruent means corresponding sides are equal and corresponding angles are equal or proportional. Understand? Two triangles are said to be congruent, corresponding sides are equal and corresponding angles are equal. Understand? Keep in mind that point. And look here, for the second part, look here, AB is a straight line, isn't it? AB is a straight line and OP is the midpoint. And And we know that AB is a straight line means, can you say what is the angle in a straight line? Angle in a straight line is 180, linear pair, isn't it? Angle in a straight line is 180, right? All this angle in a straight line is 180. Therefore, we can say that OPA plus angle OPB is equal to 180. OPA plus OPB equal to 180. And from that congruency theorem, we can say that each corresponding angles are equal means they are equal means OPA equal to OPB equal to 90 degree. That is why 90 plus 90 you will get 180. That means OP is perpendicular to AB. That means OP, this is the notation, perpendicular to AB. Hence proved. OP is perpendicular to AB, hence proved. Okay, do that.